Hello everyone, welcome to another video. So today we'll be discussing about the transpose of a matrix. So first of all, what is the transpose of a matrix, right? So transpose of a matrix, it is obtained when the rows and columns of a matrix are interchanged. And for representation, we'll be using AT, like A raised to T, that is A transpose or A dash. These are the representation letters used. If the matrix is A, then A transpose or A dash it's used. So I will explain it through an example so it would be easier. So first of all, we are having a matrix A like this. Then how to find out the transpose of the matrix, that is A dash, means you have to just interchange the rows with the columns. So if you check, this is the first row, right? Now the first row becomes the first column in the transpose. First element 2, second element is 5. So whatever is there in the row, make it into the column. Then next second row becomes the second column. So it's 9 and 7. So this is the transpose of the matrix A here. So first row becomes the first column and second row becomes the second column. So if you check, the order of the first matrix is 2 by 2 and the second matrix is also 2 by 2. Here there's no change in the order because it is a square matrix, but if it is a rectangle matrix, the order will change. So let's see how it changes now. So if you check here, we are having another matrix B. So it is of the order, here we are having 3 rows, right, and 2 columns, right? So it is a 3 rows by 2 columns matrix. Now whatever is there in the row, we have to shift it to the column now to get the transpose of the matrix. So if you check here, so first row has the elements 3 and 2. So the first column should have the elements 3 and 2. And next row becomes the next column. So 4, 8. And the third row becomes the third column, 6 and 7. So now if you check the order of the transpose matrix, it has 2 rows and 3 columns. And when you compare the order of the transpose matrix and the real matrix, the order is just interchanged, right? So we are having 3 by 2 in the real matrix, but in the transpose we are having it as 2 by 3. So just the order is changed, opposite. So that's what the elements of the row becomes the elements of the column. So that's what happens in the transpose of a matrix. So now we'll be looking at the properties of transpose of a matrix. So first property is, if you are having an A matrix, if you are taking the transpose once and then taking the transpose again, it will be equal to the initial matrix A, that is A transpose, whole transpose will be equal to A. Now second property is, if you are having a constant K and you are multiplying it with A matrix and then taking the transpose, it will be equal to K times A transpose. Third property is such like A plus B, the whole transpose, is equal to A transpose plus B transpose. And fourth property, how it works means AB, the whole transpose, is equal to B transpose A transpose. Actually only in the final case, if you check, the order just reverses, right? Here we are having AB in the multiplication, but here we are having B dash A dash. So actually the order changes for multiplication. So let's see with an example. If we have this as the A matrix and this as the B matrix, right? So the order, if you check, the first one has 2 by 1 order and the second one has the order 1 by 2, 1 row and 2 columns, 2 rows and 1 column. So first let's check out A transpose, whole transpose, right? So first let's do A transpose, right? changing the rows with the columns. So first row with the first column, so 2, second row with second column 3. So this is A transpose. Now let's do A transpose whole transpose. That means this matrix which you have found out, we have to take the transpose of it again, right? Now first row has to be replaced with the first column, 2 and 3. So if you check this matrix A double dash, it's actually equal to the A matrix, right? So A dash whole dash will be equal to A matrix itself. This is our first property proved. Now let's go to the second property, K A dash. Alright, so instead of K, let's have the constant as 2 and let's multiply with A, right? So 2A will be equal to 2 times the matrix, right? Multiply with each element the constant 2, so it becomes 4, 6, right? Now what we have to do means we have to do the transpose KA the whole dash, right? 2A whole dash, so it will be equal to this element of the row replaced by the element of the column 4, and element of second row replaced by element of the second column. So this is our 2A whole dash, right? Now let's do K A dash, right? We already found out A dash in the first one, so let's multiply 2 with just the elements of the A dash. If you check A dash, it is 2, 3, right? This is 2A dash. If you check A dash, we already found out, right? So just multiply 2 with the matrix. If you check, 2 times 2 would be 4 and 2 times 3 would be 6. So if you check this one, 2A dash, it's actually equal to 2A the whole dash. So this property is also now proved. So now let's prove the third property. So we are having A matrix as this one and B matrix as this one. So now we can do A plus B the whole transpose, right? So A plus B means first you have to add both the matrices together, right? So if you check, we have to add these two matrices. So 2 plus 1 would be 3, adding the corresponding elements. 0 plus 9 would be 9 itself. 3 plus 7 would be 10, and 7 plus 8 would be 15. So now we have to take the transpose of the whole matrix, right? A plus B whole transpose, right? So for that one, you have to just interchange the rows by the columns. So first row becomes the first column, so 3, 9, and second row becomes the second column, so 10 and 15. So if you check, this is the final A plus B the whole transpose. Now we have to do the second part of the equation, A transpose plus B transpose. So first of all, let's find what is A transpose and what is B transpose. So A transpose, if you check, first row becomes the first column, 2, 0, and second one becomes the second column, 3, 7, right? Now B, let's take the transpose of that also, first row, first column, and second row becomes the second column, right? So now let's just add both the transposes together. So if you add both A complement plus B complement, so 2 plus 1 would be 3, and 3 plus 7 would be 10, and 0 plus 9 would be 9, and 7 plus 8 would be 15. So if you compare, both these matrices are equal. This is equal to this. So this one just proves the third property. Now let's check at the fourth property. AB the whole dash, it's equal to B dash A dash, right? Now let's first do AB, right? So if you check, A has the order 2 by 1 and B has the order 1 by 2, right? So if you check, this and this are equal, so the final matrix will have the order as 2 by 2. Now let's do AB first. 2 3 times 4 5. So first row with first column, so it would be 2 times 4 would be 8, first element. Now first row with the second column, 2 times 5 would be 10. Then now second row with the first column, 3 times 4 would be 12. And now second row with the second column, 5 3s are 15. So this is our AB. Now we have to find the AB whole complement, right, or whole transpose. So now just interchange the rows with the columns. So first row becomes the first column now, 8 and 10. Second row becomes the second column now, so 12 and 15, right? So this is our AB whole complement. So now let's check out B complement, A complement. So B complement and A complement, I have already done it for you. B complement, A complement, and it's equal. B transpose is 4 5 like this, and A transpose is 2 3. Right, now doing the multiplication, first row first column, you have to multiply. 4 2s are 8, then 4 times 3 would be 12. Now second row with each column, 5 2s are 10 and 5 3s are 15, right? So if you compare B dash A dash with AB whole dash, this matrix and this matrix, both are actually equal, right? So this proves the fourth property of the transpose of a matrix.